Hello, everyone. Thank you for coming to our February online lecture event. We are the Center for Climate Science and Engineering at the University of Toronto. We host monthly guest lectures. My name is Mohamed Jolier. I'm the CSE manager. Today, we are pleased to feature Marc Couture from the University of Toronto. So before we get started, I'd like to go through the land acknowledgement. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across the Turtle Island, and we're grateful to have the opportunity to work on this land. For those who haven't attended our guest lecture events before, we are the Center for Climate Science and Engineering, which is a research and education center within the Civil and Mineral Engineering Department at the University of Toronto, and it was established in 2019. The CSE is made up of a multidisciplinary team of faculty members participating together in interdisciplinary research at the intersection of climate science and engineering. Our center's director is Marjan, and she focuses on structural analysis. Marianette Sepolo focuses on transportation. Paul Kushner looks at the climate dynamics. Graham Norwell, Professor Emeritus, focuses on health and process safety. Daniel Posen looks at life cycle assessment. Karen Smith works on the atmospheric science. Marianne Tucci focuses on building science. Sam Markov from the University of California, Merced, focuses on sustainability and resilience, and then me, the CSE manager. So one of the key activities that CSE is doing is education around climate science and engineering. There are 2 graduate courses that have been developed and run at the University of Toronto. 8 online learning modules were developed and are available for use in Ontario higher education environments. Secondly, our faculty members are carrying out research projects in collaboration at the intersection of climate science and engineering. Also, our team is arranging outreach activities just like this one, where we invite the public or university people to give a presentation about topics that are aligned with the mandate and vision we have at the center. Now, I'd like to introduce today's guest lecture speaker. Marc Couture holds the position of Director of Sustainability Operations and Services, and is the subcommittee chair of the Environment, Climate Change, and Sustainability Operations. He is a professional engineer, project management professional, and certified energy manager with a wealth of knowledge in identifying complex energy systems and implementing sustainable energy retrofits. Throughout his career, he has worked with numerous sustainability and low energy pollution-based organizations. Marc has a proven track record of helping higher education clients to achieve their energy and sustainability goals by simplifying operations and maintenance, reducing energy consumption and greenhouse gas emissions while improving occupant wellness. With over 20 years of expertise in diverse roles, such as sustainability co-chair, director of operations, energy manager, critical infrastructure, and energy management project manager, higher education solution development, and heating, ventilation, and air conditioning solutions engineer, Marc utilizes a client-centric approach to achieve the best possible outcomes. He is also an active member and conference presenter panelist at the Association for the Advancement of Sustainability in Higher Education, Second Nature, IDEA, and APPA in the energy and sustainability community. Furthermore, Marc serves as the key member of International Society for Energy and Sustainability Research Knowledge Board. He's going to give a presentation on the University of Toronto's Climate Positive Master Plan. Welcome, Marc. We are very happy to have you today. I'm passing it over to you.
Thank you so much, Mohamed. I really appreciate that, the warm welcome. And it's nice to be back here again. I was able to do one of these lecture series in the past, and I'm always thrilled to do them and engage with our active audience. So thank you very much. I'm going to begin the presentation. I'm going to try and share my screen and get it set up here properly. So if you guys can just bear with me for a moment while I get this going properly. Let me know if this works. How's that?
Perfect.
Yeah, perfect. Excellent. So again, thank you and welcome to this lecture on going beyond carbon neutral and the University of Toronto's path to climate positive. Starting with the land acknowledgement, Mohammed, I think you just gave that land acknowledgement, so I just want to pause for a moment and recognize that this land for thousands of years has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit, and we're very grateful to be here today. The agenda for today is to go over the U of T's climate positive plan, a bit of the work that went into developing the plan, really a bit of a focus on reconciling carbon reduction with cost. I think that's a really key piece to our climate positive plan. And then we'll focus on a bit of a case study with Project LEAP. This is our first step in becoming climate positive at University of Toronto St. George campus. And we'll wrap it up with some individual action that we've launched for our U of T community at the end of this presentation. So to start, our climate positive master plan at the St. George campus. This is what we refer to as the climate positive campus. It's very specific about the campus rather than the institution, because this plan does focus mostly on scopes 1 and 2 and does not yet fully include scope 3 in terms of emissions. The University of Toronto's made a commitment for the St. George campus that we will become climate positive by 2050. So why is this important? I'd say that for some context setting here, the University of Toronto's greenhouse gas footprint is quite large when compared to others in the Ontario's broader public sector. Unfortunately, we're ranked number 3 in the Ontario's broader public sector, second or third only to the City of Toronto itself, as well as the Toronto District School Board. So you probably wouldn't necessarily think of a university as being a high emitter in this sector, but we are number 3, and we're very eager to take ourselves off that sort of top offenders list. And further, when you start to look at Ontario as a whole, and you start to look at peer institutions such as Queen's or York University, or even the manufacturing sector. You look at Honda, you look at Redpath Sugar, Chrysler, or even the Pearson Airport. You'll see that University of Toronto, our emissions do total up to numbers that are larger than these other institutions or manufacturers. And while we are efficient, we still have a very significant footprint compared to all these, and we're really eager to reduce this. So a few years back in 2019, we developed a low carbon reduction framework. And we will optimize how we produce, distribute, and consume electricity and natural gas. And on the production side, we're really leaning towards clean energy and carbon capture, and then looking to distribute that energy across our campus as efficiently as possible. And last but certainly not least, we do want to reduce the consumption at the end use, because that really does drive the whole supply chain. We created 4 principles within this framework. And the first principle, as I just mentioned, last but not least, is reduction. Obviously, the cleanest and cheapest energy is the energy that we actually do not consume to start with. So this is really our primary focus as part of our master plan moving forward. Number 2 is really balancing carbon reduction with cost. We could address our carbon issue by switching to electricity, because electricity is 5 times cleaner than natural gas. However, electricity also costs 10 times more on an equivalent energy basis. So for us, this would mean, really inflating our energy budget, perhaps from $40-50 million up to well over $200 million if we were just to do a switch. So finding that correct balance is really key for us to have a financially viable strategy. Our third principle here is to also reach beyond our own assets. The St. George campus, on our campus downtown here, approximately 12% of our emissions come from assets that we do not directly own nor influence. Examples of these would be the ROM or the Gardner Museums, the Royal Conservatory of Music, and even Victoria University or University of St. Mike's College. These are institutions where we deliver steam for heating that comes from our central plant, where we are accounting for emissions in our scope 1, but we don't own or directly operate or influence those carbon emissions. So having a plan on how we can partner with these organizations to reduce emissions is really critical for that last 12%. And the fourth principle here is fostering innovative solutions. And this ties in really well with our mission as a higher education and research institution. We really want to leverage the campus as a living lab model to foster partnerships with our academic community to achieve our carbon reductions. We have a lot of brilliant minds at U of T, and we want to leverage and engage all of these minds actively to help be part of the solution. And this also extends to developing external partnerships to implement innovative changes and solutions to sort of tackle our carbon challenges at U of T. So the climate and the campus. I'll take you on a quick little journey here about how we developed our climate positive master plan. So firstly, we engaged with AAPPA, some external consultants, I guess about 4.5 to 5 years ago now, around 2018. And they led the development of the climate positive master planning. And they really engaged a lot of stakeholders internally here at U of T. People from our operations department, from our utilities department, from our property management department, sustainability, of course, and create a lot of work sessions and stakeholder sessions to get feedback, not only from staff, but also from the U of T community. So what they did is they reviewed existing conditions, provided a lot of investigation on site to establish baselines and to sort of inform the strategy moving forward, moved into a lot of concept and development and what we call optioneering, and came up with sort of a future scenario based on our projected growth and future anticipated needs at U of T, and came up with some preliminary concept development. We then worked very closely with the AAPPA and our internal teams to figure out how we're going to evaluate all these options and come up with sort of a final concept that we could start to build a plan around. And then the last step here was a more robust financial analysis, and then leading into the final report. To give you a bit of an overview of sort of what the top 3 strategies were as outcomes or during this process, during the optioneering stage. The first one here we'll call alternative 1 was really focused around central generation of heating and electricity. Focused here in the bottom left with our central heating plant, and then feeding out in sort of a nodal approach where we would divide our St. George campus into multiple nodes or groups of buildings or clusters of buildings that would be sort of exchange energy within them to the extent possible, and then be topped up from a central location. If we move over to alternative 2, which was really more focused on nodal generation, again, we have this same theme of dividing the campus into clusters or nodes of buildings, but the generation would actually happen from within the node. So we might have 4, 5, 6, or 7 sort of mini central plants embedded within each node. And if we look at the third option, which was really local generation focused, this went more to maybe not having so much of a central plant, either at a central sort of full campus level or even at a nodal level, but focusing more at the building level. And this really moved us towards a lot more local air source heat pumps as the solution for decarbonization. And when we look at the evaluation matrix, this is the weighting that our stakeholder group came up with. We looked at several categories. We had environmental, we had resiliency, operational, social, as well as economic. And we had relative weightings here, anywhere from 5% up to 30% weighting. And the criteria here for each one, especially for something like environmental, where we're really looking at decarbonization, the efficiency, as well as the environmental impact. And for other ones, we were looking more such as social, looking at human impact, looking at the campus and the culture. And for us, after going through this weighting and evaluation matrix, we sort of landed on alternative one, sort of being the preferred alternative for the U of T St. George campus. As you can see, they were all quite close. These were, the three finalists. There was a much longer list that was truncated down to these three finalists that we started with. But alternative one, which is the, if I go back, is really the central generation focused, where we'd have the campus split up into nodal plants, but then really supported from a central plant for heating and electricity. So this is what our 2050 climate positive target looks like. I think it's worth pausing for a second to just explain the term climate positive. So as you can see here, we are basing our commitment from a 1990 baseline on the far left of the graph. And 1990, our baseline emissions for scope 1 and 2 equated to roughly 91,000 tons. And if we fast forward to 2020, we were at 93,000 tons. So a very, very similar number. But where we're forecasting to get to by 2050 is to actually go below zero. So in essence, this is net negative emissions. But I guess the team here at U of T are optimists, and we really didn't like the term negative. So we decided to rebrand this and call it climate positive. So for us, climate positive means creating a carbon sink out of our physical campus when referring to scope 1 and 2 emissions. And the idea here is that we will go into the negative territory and create some room for eventually having a climate positive institution where we'd be looking at scopes 1, 2, and 3. Now, for us, this represents a really big challenge. I think the first challenge I just mentioned was that we're referencing a 1990 baseline. If I actually go back for just a second, if we had referenced maybe a 2005 baseline, such as the federal government or some other institutions, this would have put us in a situation where achieving 37% reduction or 80% reduction would have actually been a lot easier. It would have lowered the bar for us. But going back to 1990, where we essentially have emissions that are quite equivalent to the 2020s, actually makes this quite a bit more difficult for us. The second piece that makes this very challenging is our ambitious plans for growth over the next 25 years. So from now until 2050, our forecast currently is to nearly double the campus area in terms of buildings and square footage. We're looking at roughly an 80 to 90% increase. And our climate positive targets are not, it's not an index where it's a carbon intensity per square foot. We're looking actually at absolute carbon. So an absolute carbon target, net of growth like this, when we have very ambitious and large growth plans, makes it very, very challenging. If we look at, and one other thing I'll mention on the targets here is that there's three pieces. There's the 1990 baseline, there's the fact that this is net of growth and it's an absolute target, and the third one also being that we're not looking at any offsets. So we're not looking to accomplish this target by purchasing RECs or third-party offsets. We want this to be, 80% absolute reduction on our physical campus, and we're considering for that last remaining 20% to have U of T owned and operated assets, such as offsite solar, that will serve as offsets for that last remaining 20%, but without using any third-party offsets. So another challenging consideration here is really that we have a lot of aging infrastructure. We have one of Canada's largest and oldest district energy systems. Our district steam system is, sections of it at least are over 120 years old and in need of renewal. So this is something that poses an additional challenge to decarbonizing our campus. So the three main buckets for our climate positive strategy and master plan. The first one would be to responsibly manage the growth of our campus to mitigate the environmental impacts of more space and activity. The second one here is really to renew the existing and aged utility infrastructure, and this is to ensure future performance that supports academic and research excellence. And the third one here is really to build resilient systems, resilient low carbon systems to support our carbon reduction targets with reliable infrastructure by changing how our campus produces, distributes, and consumes energy. If we dive a little bit more into that first bucket, we really want to responsibly manage our growth. And here are a few ways that we're planning on doing this. In 2020, we implemented carbon and energy budgets for all new construction on campus. As many of you may be aware, the City of Toronto is very forward-thinking and has implemented the Toronto Green Standard. The university really followed in lockstep with the City of Toronto, and we implemented our own utility performance and energy modeling standard that kind of sits on top of the TGS and raises the bar a little bit. So for us, on average, we're looking to sort of achieve roughly a TGS tier 2 or tier 3 in terms of GHG intensity or total energy use intensity for our new construction on campus. And this really serves to mitigate a lot of the impacts of growth by really building efficiently and mitigating the carbon impacts of new construction and growth. Part of our plan here is also to extend our district energy systems to all of our new construction and to also leverage these opportunities to increase the use of renewable energy. And this also includes things like geo-exchange systems. For a lot of our new construction, as we're going and preparing the site, we're planning to drill down boreholes for geo-exchange systems and also to leverage rooftops and facades for renewable energy generation with things like solar PV or solar thermal. When we get to that second bucket of renewing our infrastructure, part of our targets here are to really try and eliminate fossil fuel-based heating as a primary source. A campus like ours with the age, there's always going to be a need for some sort of combustion on campus, but we really want to try and actively move away from fossil fuel-based heating as a primary source. Part of this also entails trying to move away from steam distribution and moving more towards hot water. And also renewal and electrification of our central power plants. We definitely want to significantly reduce existing building energy use through deep energy retrofits. As part of our existing sustainability standard that we launched in 2020, we do have those targets for new construction that sort of sit on top of the Toronto Green Standard, but we also have targets in here for renovations and retrofits. So these targets typically look at reducing our energy use intensity for existing buildings by a minimum of about 35%, and with stretch targets to sort of increase that energy use intensity reduction by 40% or more. When we're looking at third bucket for building resilient systems, this is where the nodal approach really helps because each node that we mentioned earlier in alternative 1 would be fed from adjacent nodes. So being able to share that energy across campus is really critical in decarbonizing our campus. We want to increase the use of electricity to heat our campus using technology such as geo-exchange and heat pumps. And having these interconnected nodal plans to increase that redundancy and resiliency is a key part of our master plan. Part of this, it's not just thermal, but it's also introducing new interconnected electricity feeds to increase this reliability. We currently have, many feeds on our campus, but their distribution of the areas they serve is not really balanced. So we're looking to achieve a better balance there. One of the highlights of this master plan is a project that is nearing completion. And this is Canada's largest urban geo-exchange system. So as part of our landmark redevelopment project in our historic campus around King's College Circle, we've been redeveloping King's College Circle to make it pedestrian friendly and redirect all vehicular traffic underground. So while we're doing this, as I mentioned earlier, when we're doing any new construction on campus, we're looking for opportunities to drill geo-exchange boreholes to help promote the use of renewable energy. So in this project, we drilled over 370 boreholes down to a depth of just over 250 meters, which is almost half the height of the CN Tower for context. And these boreholes, what they're essentially going to do is take surplus heat from the summer months, from things like our chiller plants, and take that energy and move it into the ground and store it within the ground. So basically using the earth like a large thermal battery, where we can charge this battery during the summer months, and then we can extract that energy that's been stored seasonally during the winter months to offset fossil fuel consumption in our central heating plant. As part of this project, we're also looking, if you look at the top right corner of the diagram here, we're looking to create what we call a subterranean classroom. So we're actually going to try and take this technology, out of the mechanical rooms and kind of bring it to the fore, where we can have professors and guests come in and use this as a teaching aid to really demonstrate how these systems are used and how they're applied by basically having a glass wall that will let people peer into our mechanical room and use it for demonstration purposes. So when we look at the master plan, and when we see how it stacks up on this wedge chart, at the very top here in the dotted red line, you have our business as usual. And if you recall, we looked at basically doubling the campus surface area in terms of the square footage for the buildings. So business as usual, just building this out to code would significantly increase our scope 1 and 2 emissions. So the building design standards that we implemented that enhance or go a little bit beyond the Toronto Green Standard go a very long way to mitigating the impacts of that growth. And that's indicated here in the light gray. The next layer here is the deep energy retrofits of our existing buildings. So as I mentioned, our standard also applies to all of the existing campus, and going into these buildings and electrifying them and giving them deep retrofits to reduce the amount of energy they consume on average by 35 to over 40% will also have a big impact on reducing from our baseline. The yellow wedge here is really our utility infrastructure renewal and the electrification. This is more at a nodal plant and central plant level, but also permeates into the buildings and the retrofits. The red piece here you can see is the impact of having those thermal batteries with the geo-exchange systems, where we can really store heat seasonally and take that excess from the summer and store it in the ground and use that heat to offset generation and distribution of new heat in the winter months. And this last piece in green that you see is really the renewables. So this is the remaining 20 or so % that we won't be reducing on campus, but we are going to be offsetting with the U of T owned and operated renewable energy assets. These will be assets such as solar farms or wind farms that will be on U of T owned land. And this next slide here speaks directly to that. So By leveraging offsite generation, we're going to try and mitigate the impacts that last 20%. So U of T has an opportunity at several sites across Southern Ontario to install larger scale solar installations to meet this need. And this will obviously be in addition to the solar that we're actively installing on our physical campus in downtown Toronto. Hopefully with virtual net metering, with our main accounts at the St. George campus, this will help ensure the projects are financially feasible. We recognize that virtual net metering isn't currently possible, but we're hoping that in a few years' time, this might be something that will be very viable. So as part of our sort of guiding principles here, this first 80% in the bar on the right, this will be absolute carbon reductions, and this last 20% roughly will be serving to get us into that negative territory. And to provide an example, here's 4 sites that we have that are owned by the U of T. On the top right, we have Gull Lake, where we've done a feasibility study, and we've figured out that we have capacity for roughly 5 megawatts of solar PV up at Gull Lake. If we go down sort of in the GTA area, we have the UTIAS campus. Here we also feel like we have roughly 5 megawatts of capability. And if we go up to the Koffler Scientific Reserve, sort of up just north of Aurora, here we think we have an excess of 20 megawatts of capacity there for renewable energy generation. And off to the west, we have Hart House Farm, where we have an additional 5 megawatts. So all in all, we think we have between 35 and 40 megawatts of capability off campus, but then we have significant capability on campus as well for renewable energy generation. So here, now we're going to talk a little bit more about making the electrification strategy work. So we talked about principle 2, balancing carbon with cost. This is a really tricky one to overcome. And we do need a very robust commodity strategy to mitigate the electrical cost impact, as I mentioned. 10 times more expensive. As I said, this would boost our operating budget, from 30 to 50 million up to well over 200 million. So this just really isn't financially feasible. So we're looking at strategies to try and mitigate the impacts of that extra cost of electrification. In terms of deferred maintenance, our central plant boilers were installed in 2 phases. In the 50s and into the late 50s, early 60s. They're all sort of beyond their useful life and much in need of replacement. And it's the ideal time to really look to replace fossil fuels with electricity when we're renewing these assets. If we look at the cost of electricity, to give you sort of a rough breakdown, and I acknowledge this might be a little bit dated, but I think the overall message still holds. There's 3 primary categories. The first one being global adjustment, then you have your distribution cost, and you have your commodity cost with the HOEP. And you can see that when you look at those 3 stacks, the global adjustment cost is quite high. It's the largest piece, followed by the regulated distribution cost, and then lastly, the actual commodity cost. And when you compare it to natural gas at the time that this was prepared, you're roughly at the equivalent of just under 2 cents per equivalent kilowatt hour, versus the electricity at the hope price sort of being roughly the same before efficiency is taken into account. So when we do look at large consumers such as the U of T, in Ontario, we have the opportunity to become a Class A customer. And there's also Class B customers. And the main difference here is how the global adjustment cost is billed to the customer. In Class A, it's billed as a coincident peak demand ratio, versus in Class B, it's calculated based on the actual commodity consumption, so the actual energy. So when you do put this into, when you become a Class A customer, you have the ability to really manage and reduce your global adjustment costs. And this has the impact of bringing your overall electricity cost a little bit closer to the equivalent natural gas cost on a per energy unit basis. So this is part of our strategy to sort of bridge that gap between the much higher cost of electricity and the low cost of natural gas. So if we look at the demand profile for our St. George campus, you can see that in the winter months, we peak well below 20 megawatts. But when you get into the summer months and you have a lot of extra cooling that draws a lot of energy, we get closer into the 30 and above megawatts per month. So on a month-to-month basis, what we're trying to do is to increase the utilization factor of our feeders and our costs that we're already paying. So although this graph doesn't perfectly exemplify that, essentially what we're trying to do is bring our utilization factor closer to 100%. So if we already have a peak that's been generated by our existing operations on campus, and we're paying for that peak for the entire month, we can try and maintain that peak and keep it stable all month and leverage, cheaper electricity that's not paying or contributing to an additional peak. From an annual basis, this is sort of a similar kind of approach where we can try and not increase our annual peak and leverage lower electricity costs. We are looking at some demand reduction measures and the potential of these measures on our campus to help mitigate those peaks. So coupling the strategy with demand reducing elements will reduce the global adjustment costs, allowing for more electric boiler capacity. And some of the examples of this, we have a gas turbine on campus. We can increase its output with some charger cooling. And this might give us, somewhere close to a megawatt in extra demand reduction capability. If we do things like campus-wide LED lighting conversions, this also could give us some room where we could operate an electric boiler with a little bit more energy. And the last one here is energy storage. We're looking at things like ice storage or battery energy storage or things of that nature. And we think that we can go, 3 megawatts, maybe even as high as 5 or 6 megawatts. So reducing the electrical demand on campus, this creates more carbon reducing potential for us. So the more we can reduce the demand of our existing operations, the more room we have in our feeders and our existing electrical infrastructure to actually run things like heat pumps or electric boilers that will produce cleaner heating and help to offset fossil fuel heating. The electric boilers that we're contemplating for our campus, although they won't get anywhere near half the peak demand, throughout the year, they can actually go a long way to reducing carbon emissions on our campus. And we can easily get to 50% or greater emissions reductions through the partial electrification of some of our infrastructure around the heating of our campus. And this brings me into Project LEAP. Project LEAP is really the first step, the first concrete action in our climate positive master plan. If we look at some of the highlights of Project LEAP, and just to give you some more context here, we launched Project LEAP. We launched the qualification for this project back in May, and that led to the request for proposals that began in July and ran until November. And we're currently in our due diligence phase where we have a preferred partner, and we're trying to iron out some of the details of the project proposal, which will then hopefully be approved by our governing council come June, and we can get into an implementation contract, which is targeted for July of this year. So some of the main goals for Project LEAP that were in our procurement documents is we aim to reduce the emissions of our St. George campus, both scope 1 and 2, by over 50%, or a net minimum 46,000 metric tons of carbon annually. And this will introduce the aforementioned electric boilers into our central heating plant and really start that transition away from fossil fuels as mentioned in our master plan. So this will have to really walk that fine sort of tightrope line on the balancing carbon with cost, and use some demand reduction strategies to sort of bring that cost of electricity closer to the cost of natural gas. And then we'll be leveraging things such as the higher efficiency of heat pumps and such to further bridge that gap. We're looking at savings for this project that will be derived from avoided carbon taxes. As many of you know, our carbon tax right now is at $65 per ton, and this is on a quite aggressive escalation ramp up to 2030, where it'll reach $170 per ton, and is projected to keep going beyond that with a fairly aggressive escalation rate. So these future avoided carbon taxes, with scope 1 emissions here exceeding 50,000 tons per year, it does add up quite quickly. And at the 2030 rate, this will represent for us 9 million, 10 million or more per year in avoided carbon tax. And that is what's being used to actually create the financial business case for Project LEAP. And the last piece here that's also really key is we have significant mitigation of deferred maintenance risk. So when we're changing, central boilers that heat 80% of our campus, that as I mentioned, were installed in the 50s and 60s. When we start changing out these assets and renewing our 120-year district energy system, this does have great benefits in adding resiliency and mitigating deferred maintenance. If we look at the impacts of Project LEAP, so as you recall, we had a very aggressive sort of slope to go from where we were in 2020 to where we really want to be prior to 2050. And you'll recall that the dotted line for business as usual actually went up from 2020 and represented the impacts of growth in business as usual. So not only are we going to be able to accelerate our existing and already aggressive trajectory towards our landing just before 2050, but Project LEAP is actually going to have the impact of accelerating our impact by over a decade. So if we look at sort of a summary of Project LEAP, and by the way, Project LEAP stands for Low Emissions Accelerator Project. And when you see that it's going to accelerate our plans by over a decade, that's exactly what it was intended to do. So what we're looking at here is really partial electrification of our central heating plant, adding resiliency as well as fuel diversity. Our existing plant does have some diversity in the form of number 2 fuel oil for heating, as well as natural gas. But now we'll be adding in addition to those 2 fuels, we'll be adding in electric heating. We're also looking at things like I mentioned, like battery energy storage and addressing that deferred maintenance. Also looking at addressing some deferred maintenance, not just in the boiler plants, but also in the existing larger chilled water plants. Adding thermal storage here, as well as load shifting and replacements of chillers in favor of heat pumps in some of these plants. We also really want to have a demonstration and innovation component here that really serves to support our core mission. Things like carbon capture and conversion to ethylene, as well as having various demand response technologies which can be used as a demonstration. If we look in terms of the building retrofits, Project LEAP does involve a lot of district energy retrofits and electrification, but we did focus also on 6 buildings that we're going to be doing deep energy retrofits in. The first 3 buildings are all lab buildings, which are high energy use intensity buildings on campus, where we felt we could have a really large impact. So in these lab buildings where you have a lot of 100% fresh air systems and they are very energy intensive, we're looking at strategies such as active heat recovery, where we'll actually use heat pumps to subcool the exhaust and use that exhaust stream as a heat source that can be redirected towards heating these buildings and heating the rest of the campus. We're also looking at deep retro commissioning of these buildings to sort of get some optimization and control strategies in place to further reduce the energy use intensity. And some other smaller measures, things like LED lighting control systems, conversions to low temperature hot water for heating as well as for humidification. Looking at some energy storage to really sort of top this up and allow for some load shifting. And these buildings, each of them, the minimum target is 40% energy use intensity reduction. The other 3 buildings are more administrative buildings with lower energy use intensities, but older buildings, so with more aged assets and deferred maintenance liability. We're also looking at doing a lot of heat recovery, some active heat recovery in these buildings as well. And we're looking also to disconnect from our third-party steam provider and to try and connect this either to our own district energy system or to create sort of a standalone low carbon node with these 3 buildings that are all adjacent to each other. Similarly, we're going to have LED lighting retrofits. We're going to have some retro commissioning optimization, some energy storage, as well as some renewable energy generation. Overall, we're looking at trying to exceed a 35% energy use intensity reduction within these 3 buildings. In terms of the financials for Project LEAP, we've completed a feasibility study with independent third-party costing as well as a technical peer review. The deferred maintenance funding can support a portion of this project, but we've also been exploring other funding that's available, such as the Low Carbon Economy Challenge and the DIP grants. As I mentioned, the avoided carbon tax savings will be leveraged for project loan payments. And we're still exploring a few other avenues for funding and financing. One of our big partners in this project, of course, is the Canadian Infrastructure Bank. The Canadian Infrastructure Bank, is an impact investor. One of their mandates is to decarbonize and to support decarbonization projects. So this was naturally a very good fit for them, where we're looking to go and do a deep decarbonization of the U of T campus. So they have committed to financing up to 40% of our total project cost. And this reflects roughly $56 million in contribution in terms of a loan from their institution. So now shifting gears a little bit, I'd like to talk to you quickly about some of the sustainable change that we're promoting on campus through our Sustainable Change program. To give you a bit of background, we previously had a Green Suite sort of engagement program. We were looking to improve this program on how we connect, how we engage, and how we actually empower the community at U of T to be change agents and to be examples in how they move beyond traditional green to more holistic sustainability. And this whole program is really guided by the UN Sustainable Development Goals. And we really aim for it to sort of be a best-in-class program and have it be very efficient and automate as much as we can to make it really easy and simple. So the main goal here is really to engage as well as empower our students, our staff, and our faculty, and to really encourage that behavioral change, to foster friendly competition, and to create a cultural shift towards sustainable practices, as well as accountability. Within this suite of programs, we have 5 currently, and we'll be expanding this year to 6. They currently are sustainable labs, sustainable offices, sustainable events, sustainable residences, as well as sustainable courses. If we look at sustainable labs, any labs or research groups can certify. The programs cover energy, water, waste, but also chemical procurement, as well as lab operations culture. If we look at sustainable offices, some of the themes are very similar here in terms of energy, water, waste, but also meetings and food and transportation, procurement and culture again. And this is, for anybody, an individual workspace. It can be a team or a unit, a division, a whole floor, which would be great, or even a department. If we look at sustainable residences, this is for people can certify individual rooms, again, a unit or a floor, or even a whole residence building. And this covers energy, water, and waste as the staples, but also transportation and sustainable lifestyles. If we look at events, this is meant to really have sustainable events that are being held on our U of T campus. It can be any form of event. And what this does cover is the setup, the food, the catering, the waste, and also the closing of the event. Looking at sustainable courses, this is the 5th one in the suite. This is available to courses in any discipline or subject, and it covers a sustainable courses slideshow, so a short presentation given at the start of the course throughout the semester, and course materials, the delivery, as well as the engagement. So the program here is really about having a process to certify. And the certification at the end here, based on the number of points that are achieved, can go anywhere from bronze all the way up to platinum. And participants are rewarded with a badge of honor that they can include digitally in their emails or on a website or anything of that nature. In terms of the process, the participants review the program, the highlights, the resources. They complete the certification form online. The Sustainability Office will review the submissions and validate that they've been done correctly. And then the web application automatically sends a certificate, a badge, the ribbon, and as well as resources for improvement, so someone can look back at the way they filled out the certification and the questionnaire and learn from it and have something to take away. So thank you very much. I appreciate the time and the opportunity to speak with you all today and to share with you a little bit about our Climate Positive Master Plan, as well as Project LEAP and our Sustainable Change Program.